Hi everybody, welcome to Test 3 review in pre-calculus. As always, you see the topics that we cover on the top, and this time we do have the formula on that side. Right, first we'll prove some identities. So let's look at 1 and 2. So first, if we see a fraction, we will eliminate it. So multiply the second on both sides, or cross multiply, either way. I cross multiply here. Right. Now we have cosecant, secant, cosine, and cotangent. We need to. It is easier to change to sine, cosine. So we'll do that. Cosecant is 1 over sine. Secant is 1 over cosine. And inside we have cosine of x. And cotangent is 1 cosine over sine. So we see there's sine and there's cosine. So the least common denominator is sine and cosine. And we're going to multiply both sides like that. So multiply both sides by sine x cosine x. And that gives us sine x cosine x plus sine x cosine x times sine x, we have cosine x. And sine x cosine x times that, the sine x will be there. Inside the parentheses will stay the same. Next, we will multiply it out because there's nothing can be done on the left side. So multiply it out, we have sine x cosine x, and sine x cancel out, plus cosine x. Now this is true because they are equal. So this one is true, everything above that will be true, and that the beginning statement is also true. So the last one is true because they are the same. So everything above that will be true, especially that. Right. So that usually we prove identity. Try to eliminate fraction. If there's sine cosine, if there's anything other than sine cosine, we can always convert to sine cosine. And at the end, we should have an identity. Right. That's the first one. Look at the second one. We do the same thing. We do the cross multiply. So we have sine x cotangent square of x equal to 1 plus sine x times cosecant x minus 1, right? So we get rid of fraction. Now we still have that to be converted to cosine over sine. So we have sine x cosine square over sine square. We will multiply later because cosecant x is 1 over sine x. Right. Now, first thing we can see is the sine x and cancel with one of the sine x here. We will have cosine square equal to sine x. Now we'll multiply it out. We have 1 over sine x, 1 minus 1, sine x times 1 over sine x, that is the plus 1, and sine x minus 1 minus sine x. Yes. So here we have those to cancel out. Next, we only have that left. And the least common denominator in this case is just sine x. So we will rewrite that cosine square cosine square over sine x. Right, we multiply the whole thing by the least common denominator, sine x. Right, multiply it out, the sine cancel out. We have cosine square, and the sines cancel out. We have 1, and this gives us sine square. Right, this should be obvious now that we need to add the sine square on both sides. Because every time we have the cosine square and sine square, more than likely it is the Pythagorean theorem. I should say Pythagorean identity. Cosine square plus sine square equal to 1, which is true. Since this is true, every line above that will be true, including the first one. Right, so that's how we usually prove identities. If there's fraction, eliminate that. If there's something other than sine and cosine, try to put that in terms of sine and cosine. And if we have a square, more than likely it is Pythagorean identity. Right, so that's the first two, the basic of proving identities. Right. Next we have the sum or the difference identity. So when we look at this, it'll be like 3, 4, 5. I will do 3 first. Right. So sine of 165, so we have to look for something that is add up to 165, and we only know the values of 30, 45, and 60, and those the multiples of those angles. So I would use 165 like 120 and 45. That would do. That will add up to 165. Of course, you can use different combination like 135 plus 30 or something like that. So the sum of the sine will be here. I mean that. So we will have sine of 120 cosine of 45 plus cosine of 120 and sine of 45. Right. So actually that's a unit circle right there too. So you can see 120. So we have that. Anyway, so sine of 120, that is multiple of 60. So it will be positive square 3 over 2. Cosine 45 square 2 over 2 plus cosine 120, that's also multiple of 60, which is 1/2. But it's going to be negative because in the second quadrant. So we have square root of 6 over 4 minus square root of 2 over 4. We can just combine the denominators. And that's what we have. So that was 3. Yeah, very straightforward. Try to break the angle. Pi over 12, that is half of pi over 6, which is 30. So this is 15 degrees. 15 degrees, you can say 45 minus 30. So pi over 4 minus pi over 3. Sorry, pi over 4 minus pi over 6. Right. Right. Next, we do number 5. So now we find sine of alpha minus beta. So first, sorry, this is going to be sine of alpha cosine beta minus cosine alpha sine beta. Right. So let's see what we have. We have sine of alpha and we have cosine of beta. So we know those two. I'm just going to say sine alpha 15 over 17, cosine beta 5 over 13, and minus, we do not know either one of this. Right. So we can do that rather easily. This is the fundamental technique. So we use the right triangle angle alpha, 15 over 17, opposite over hypotenuse is going to be a sine. So do the Pythagorean theorem, 17 square minus 15 square, I think it's 64. So that is 64. So this side is going to be 8 or negative 8. So this side, let that be x is equal plus or minus square root of 64, which is plus or minus 8. We need to determine that. In this one, we have the angle between pi over 2 to pi, meaning in quadrant 2. Quadrant 2, x is negative, so we have to choose a negative here. So that is negative 8. And finally, we need cosine of alpha adjacent over hypotenuse. negative 8 over 17. Right, so we have cosine of alpha. The same technique can be done to find sine of beta. So we have the angle beta here. Cosine is adjacent over hypotenuse. Now we just need to find this side, that will be y. So 5 square plus y square equal to 13 square. Y square will be 144. Taking the square root, we have y equal plus or minus 12. Now we see that this is in quadrant 1. In quadrant 1, everything is positive, so we choose positive. And with that, we have sine of beta is opposite over hypotenuse, so be 12. I'm sorry, 13. 12 over 13. And now we put everything we know here. Cosine alpha, negative 8 over 17. And sine beta, 12 over 13. And we just have 17 times 13 at the bottom, which is 221, and 5, 15, 75. 8 and 12 will be 96. Uh, 75 and 96 will be 171. Right, so we just like that. So straightforward, the formula for the sum or the difference, because the difference is right below that. Yeah, we just using those two, and we don't need to know all of them. If we're not, we need to find it. Right. I forgot that we do need to have this for the test, so I'm going to add the topic here. Right, I'll look at 7 here. To combine sine and cosine, we will divide by, to combine this, let me write. To combine sine and cosine of that, divide and multiply by square root of a squared plus b squared. So what we'll see here, from this, first we will divide square root of 5 squared plus negative 12 squared. Right. Actually, I'm sorry. We divide inside and multiply outside. Sorry. Alright. So multiply first. And then we divide inside. Right. So do that, we will have 25, 144, 169 square root will be 13, and so we'll have 5 over 13 cosine of alpha minus 12 over 13 and then sine of theta. Right. So yeah, we just group the coefficient and we have that. Now what we look at the two formulas that we highlight over there. If we have sine, cosine, and then cosine, sine, that will be good. So what we'll do is that we'll let this equal to sine of phi, and this is cosine of phi or phi, or whatever you call it. So in that case, we will have 13 sine phi or phi cosine theta minus cosine phi sine theta, and the formula we have on that side will give us 13 sine of phi minus theta, and of course we should write that where sine theta is sine phi is equal to 5 over 13, or if we take the inverse, we can find the angle phi, but when we combine, that's what we can combine. Of course, we can also use different identities. We can use these two as well, and we say that equal to a cosine and that equal to a sine, and we still can combine them. Right, that's how we combine the sine and cosine. Right, double angle formulas, and then half angle formula. I will do this quickly. Cosine of 2 theta equal to 2 sine theta and cosine theta. Right, we do know cosine theta is 7 over 25. We can find sine of theta easily, and I will start, but we will not finish. Theta will be adjacent over hypotenuse. We'll find out what is the opposite, and then we find out what is sine. Once we do that, we can finish the problem. Right, so that is the double angle formula. By the way, double angle formula is here. Right. Yeah, similar problem here. Now we use half angle formula. Let's go to the formula first. Yeah, so on that side, cosine of alpha over 2 is plus or minus 1 plus cosine of double this angle, so we just cosine theta over 2. Now just put everything we know. Actually, that's the only thing we know, and that's all we need, really. I will multiply everything by 2 just to simplify things. So 2 I'm sorry, cannot be 2, but be 5. So we have 5 minus 3 over 10. So we have plus or minus 2 over 10 or 1/5. Right. The only thing need to determine is whether it's positive or negative. To do that, we need to see what quadrant alpha over 2 is. We have alpha is between these values. Now we divide everything by 2 or multiply by 1/2. We will have that alpha over theta over 2 is less than 3 pi over 4 and pi over 2. We can see that this is 135 and that is 90 degrees. So clearly it is in quadrant 2. In quadrant 2, cosine is negative. So the answers won't be negative. Next we'll go to application of the right triangle. Look at number 14. So I'll try to draw a sketch first. From the edge of the 1,000-foot cliff, the angle of depression to car value below. So we have a 1,000-foot cliff, and on the edge of that we'll see 2 cars below. Let's just we see one of them is 22 degrees with the angle of depression. Of course, angle of depression is met with the horizontal line. So one of them is 21 degrees and the other one is 28 degrees. This angle is 28 degrees. Right. So we have 2 triangles, the one in red and the one in blue. Right. So first, if we look at the red triangle, right triangle, first we need to determine that this angle here 28 degrees, this also 28 degrees. So 28 degrees here, and that is 1,000. We need to find this distance. By the way, the question asks us what is the distance between the 2 cars, so we do not know this. So when we look at the red triangle, we have opposite and we have, that's all we have. But we look for the adjacent. So adjacent here, let's call this is A, B, and C. we look for the sine AB over HH. Sorry, to start with 28 degree first. So 28 degree, we need to have opposite over adjacent, which is tangent. So we have AB is equal to 1000 tangent of 28 degree. Now we look for the one in blue, the big triangle. That is 21 degrees, so is this 21 degree. And again we have opposite, also 1000 over the adjacent, and that is tangent. So we have AC is 1000 sorry, it's not multiplying, it is dividing. AB is equal to 1000 divided by tangent 28 degree and divide by tangent of 21 degree. And finally, the distance between them, BC, is equal to AC minus AB, and AC is 1000 of tangent 28 degrees, 21 degree for AC, minus AB is 1000 over tangent of 28 degree. And I'll put this in the calculator to get the answer. So we use calculator. I'll make sure that it is in degree mode first before I do this. So 1000 divided by tangent of 21 degrees minus 1000 divided by tangent of 28 degrees. So I have 724 feet. About that. Right. So we're going to have two right triangle, and we just do both of them, find the difference. So that will be that. Next, we will solve the triangle in general, what we call the oblique triangle, where we do not have a 90-degree angle in any of them. Right. So we look at 15. So 15, in this triangle, what we have is angle B, angle A. So we know two angles, meaning that we know the last one too. So A plus B plus C is 180 degrees. So angle C is the common supplement from those angles. Minus 26 minus 51 is 103 degree. Right, so now we know that we can put it here. Right. What we have next is a pair of opposite sine angle. So that is the law of sine. So we write sine of A, which is 103 over 22. We know that. Over sine of 51 degree, and we do not know this sine, which is opposite to angle B, so little b. and sine of 26 opposite to angle A is the sine A. Right. So pretty much that. It's very simple. From here, just group that ratio and we can solve for B. So from here we have B equal to 22 sine of 51 over sine of 103 degrees. So calculator, sine of 51 divided by sine 103. So 17.5, let's say. Right. Need to check, make sure it is in degree mode. It is. And also I would need to do this. Next, need to solve for A, so we use this two ratio. And we have A equal to 22 sine 26 degree over sine of 103. So we have 22 sine of 106. I'm sorry, sine 26. Divide sine of 103. And it's 9.89, so that's about 9.9. Right, so pretty much we have everything for that triangle, all the sides and all the angle. Same thing will be done on 16. Since we know 2, we know the last angles, and the rest will follow easily. So we did 15. Now in this case, we have the sine angle situation. Sorry, let's put the calculator away. 17, 18, and 19, those are the ambiguous case. I'll do 18. So because it is ambiguous case, we really don't know what the triangle will be. So that's why usually you will not be given a triangle. So let's just try to draw it in general. Yeah. Just a generic triangle. We have A. We know that A, B, and C. What we know is that angle A is 30 degrees, sine A is 6, and sine B is 12. Right? So this is the ambiguous case where we have opposite sine and angle. So that is law of sine, the only thing we can do. So we write out sine of 30 degrees over 6 equals sine of, let's see, angle B, which we don't know. We do know sine B. And we have sine of C, don't know, and over sine C, we also don't know that. Right. Now we pick a ratio and then we solve for the missing information. Obviously, we need to use this ratio to solve for sine B. So we have sine B is equal to 12 sine of 30 Oh, it's going to be easy because of the special case. Right, so we do that. 12 sine of 30 and just have one. So we have two different scenarios here. B equal to sine inverse of 1 or B equal to the supplement. Remember trigonometry equation, if we have sine, that is we have the supplement as well. Turn out to be not much different in this case. Sine of 30, sine inverse of 1 is 90 degree, so 180 degree minus 90 degree is just 90 degree. So both of these cases will be the same. So we pretty much have only one triangle in this case. I said it's not very special about this. So instead of do that, we do 19 instead. Right. Looking for that is a little less special about this. This one we do have the 90 degree, which is the right triangle, and there's nothing. It is special case. Right. We know angle B is 22 degrees and sine B is 16.8, and A is opposite to that is opposite to A, 22.42. And put everything in the law of sine. We start with the sine A that we don't know over the sine A we do know, equal to sine of 22 degree over 16.8, and we do not know anything about C, angle C, cosine C. Right, and we will do this and solve for the missing information alpha, A. So we do right, still in degree mode, which is good. Right. So we have 22.42 times sine of 22 degrees over 16.8. And we have 0.4999. That's close to 30 degrees. The inverse, that is. Now, that is sine of A. For the inverse, to solve for angle A, there will be two scenarios. We have sine of A, I should say A inverse, equal to sine of, I should say the angle A equal to sine inverse of that. Or the supplement to it. This I have 30 degrees and this is 180 minus 30, it's 150 degrees. So we have two cases. One is 150 and the other one is 30. Right. At this moment we see that the B is 22 plus 30, so there will be a lot of room for angle C. There's B 22, A is 150, we add up, that's still 172. We still have 8 degrees left for the third angle, so that's still fine. So in that case, we will have two solutions. Right, first we use A plus B plus C equal to 180 degrees. B is always 22. So in this case, if A is 30, we find angle C is 180 minus 22 minus 30. That is 128 degrees. And on this side, we have C equal to 180 minus 22 minus 150, and we only have 8 degrees. Right. So we have two solutions for C, and once we know the angle C, we can find the sine C. So now let's write out what we have. Originally we have sine of 22 degrees, that is B over 16.8 equal to sine of C. Now we know it's 128 over little c we don't know, and we solve for it. I just do this quickly. So we have 35.3 here. And on this side we have similar thing. (22 degrees, 16.8 sine of C, 8 degrees over little c, and so little c is 16.8 times sine of 8 degrees over sine of 22, and do that we should have 6.2. And finally we should write the answer as follows. Angle A, in this case 30 degrees, B 22, C 128, and sine little a 22.42, little b 16.8, and little c 35.3. Right. Just need to check that the biggest angle will face the longest side, and the smallest angle face the shortest side. That makes sense. And we do for this as well. A will be 150, B still 22, and C is 8. Little a is 22.42, little b 16.8, and little c is 6.2. Right. Biggest angle, longest side, smallest angle, shortest side, so that makes sense. So that is when we use the law of sine. So pretty much every time we have a pair of opposite sine and angle, when we know one ratio, that is the law of sine. If not, then we use the law of cosine. So those are law of cosine. Right. Look at 20. Right. 20, what we have is for 45 degrees and 5. We do not have opposite sine angle, so law of sine doesn't work. We have to use law of cosine because we do not know this one. And also, since we know the angle A, we have to look for the formula in the law of cosine that has angle A, and pretty much that. This is B, sorry, this is C, we know. This is B, we also know. Don't know this angle. Don't know this angle. Right? So what we see here is that we use the one with the angle A, meaning we're going to use the sine A as well. So law of cosine A squared equal to B squared plus C squared minus 2BC cosine A. A squared, don't know, but that's fine, we're looking for it. B squared 5, C squared 4 squared minus 2, 5, 4 cosine of 45. Right, let's do that. Right, 5 squared plus 4 squared minus that is 20 cosine 45 at 26 point something like that. We need to take the square root, so second square root, and I want the answer, the last entry I have, so second answer. Oops. And yeah, pretty much that. 5.18. Right. Let me write that out. A squared oh sorry, 26.86. And 5.18. Something boring means something is not right. Simply because you see, if A is 5.18, then that is the longest sine here, and that's definitely not the biggest angle. 45 degree angle, it cannot be the biggest one. There should be something bigger than 45. So let's check the calculation. Sorry, that was 40. So as you see, this is a demonstration that if we have 5.18, this will not work because that is the biggest sine and it cannot face, this is the longest side, it cannot face that angle. So 45 degrees cannot be the biggest angle. So I know I make a mistake. And we have angle A, I mean sine A, square root of that. So that is the nice check. 5, 7. Right. And you see, just need to confirm that the whatever this sine is, it cannot be the longest sine, because 45 degrees cannot be the biggest angle. Anyway, so we have A. Right. What next is we have a few options. We use law of sine to find the angles, or we use the law of cosine to find the angles. I will choose the law of cosine. Remember, if we use the law of sine to find the angles, we will end up with potentially two solutions. In this case, one may work, one may not, but there will be different scenarios. So to reduce things, I will just use the law of cosine to find the angle. So let's go the one with B, for example. So if I need the angle B, I start with the sine B. B square. Of course, we can put everything we know, but we can solve for cosine B. And so we have cosine of B equal to B square minus A square minus C square over minus 2AC. Right, do that. Calculator again. Right, have a fraction B square, that is 5 square, just 25, minus A square, A is 3.57, minus C square, 4 square, over negative 2 times A 3.57 times C, which is 4, and we have that, and then cosine inverse of that, we have 82.5 degrees. Yeah, around that. And then finally, A plus B plus C equal to 180 degrees. You can find the last angle C easily. Right. So that is 20. So even though using the law of cosine to find the angle is more complicated, but whatever we have, it's just exactly one solution. We don't have to worry about line number 19 where we have potentially two answers. Even though in this case we guarantee to have one solution with these scenarios, but we still need to show which one doesn't work in the law of sine. By the way, the reason we only have one of this because in equation of cosine, we have either cosine or opposite of cosine. Opposite would end up with could be a negative angle, so we never consider a negative cosine inverse here. So that's what we have. And finally, C is 180 minus 45 minus 82.5, and we get whatever that is. 52.5, or close enough. Right. So that's solving triangle. Next, we'll convert between the polar coordinate to rectangular coordinate. This is pretty simple. We will not see this formula on the formula chart because this you need to know. And then after that we have x squared plus y squared equal to r squared, and tangent of theta is y over r, y over x, that is. Right, so very straightforward. R is -7 cosine of 2 pi over 3 and then -7 sine of 2 pi over 3. Right, will be -7 2 pi over 3 multiple pi, multiple pi over 3, which means 1/2. In the second quadrant, so that will be negative. So we have 7/2. This 2 pi over 3 multiple pi over 3 for sine is square 3 over 2, and second quadrant still positive. So we have x coordinate, y coordinate, just like that. Next, 23. This is x, this is y, originally r, theta. R squared equal x squared plus y squared, square 3 squared plus 1 squared is 4. So r is equal to 2. Usually we just keep r positive. Right, next we have tangent of theta is equal to y over x. So we take theta will be tangent inverse of 1 over square root of 3. That looks like 30 degrees, would it be pi over 6. Right, and we do need to check that pi over 6 is in the first quadrant, and this point is in the first quadrant. So that check. Whenever we have the angle, make sure that it has to be in the right quadrant. So we have the radius is, the r is 2. The angle is pi over 6, which is good. That's what we have. Next, pretty similar to what we have before. I'm going to pick some of them. So we have x is r cosine theta, so r cosine theta. And r sine theta for y. Still have 4 though. So we have r squared cosine theta, cosine square, 4r squared sine squared theta equal to 4. Not much we can do here. I think we did this in class. So Right, vectors. Right. So vectors, well, we just need to combine the vectors. I would look for the one that has 3 components instead. So number 33 instead. Because whether we have 2 components or 3 components, meaning the vector in space or vector in the plane with 3 components or 2 components, the calculations are similar. Right. So look at 33. 2v plus 3w. So 2 times vector v plus 3 times vector w, 2 times the vector plus 3 times the vector, and we just multiply it inside first. And then just combine component wise. The first 2 give us 16, negative 28, negative 21. Yeah. And we can just give the answer in this angular bracket notation. Right. Next, let's go back. 28. So the unit vector in direction of v, so that will be that. So we will take this vector here, 12 and 5, over the magnitude. So still 12 and 5. The magnitude will be 13. And then we can just split. And will be just that. Yeah. So that is the unit vector in the direction of another vector. And we do need to know that. Right. Next, let's do a dot product. So dot product. So we just multiply. Oh wait. Yeah. So multiply the first with the first, add to the second with the second, and then the last with the last. So we have 3, 2, negative 6, and that's negative 1. Dot product is just a number, so that's easy. Right. The angle between two vectors, we do have that formula. So we have that. So cosine of theta is equal to the dot product over the magnitude of the product of the magnitude. So vector u is ij, so it will be just 1 for I, 1 for j, nothing for k. W 1, 1, negative 1 over the magnitude of u, 1 square, 1 square, 0 square, 1 square, 1 square, negative 1 square. And the dot product gives us 1 times 1, 1 times 1, 0 times negative 1. And here we have square root of 2, square root of 3. So do all of that, we have cosine of theta will be 2 over square root of 6. And with that, cosine inverse of 2 over square root of 6. Have 35.26 degrees. Yes, that. Right. So that is the dot product. Right. Next we'll go to a cross product. Cross product pretty much we have again the formula, those formulas you need to know that. So wait, dot product we did 34 and 35. Cross product 36 is straightforward, so we'll just do that. I'm doing 37 because we have one of the properties of the cross product is that the cross product is orthogonal to both of the vectors. So pretty much we find the cross product here. So V cross W I J K negative 5, negative 3, 1, 2, negative 5, and negative 1. So first, cover the row and column that we have for vector I, for negative vector j, and then for vector k. Right, for I we have to cover that up. Then j, and then k. Right, and now we just need to do that. Negative 3 plus 5. I'm sorry, that is positive 3 plus 5, so that would be 8. Positive 5 minus 2 is 3, but with the minus. And then 25 and 6, 31 k. So pretty much that. So the cross product is orthogonal to both. We can also do W cross V or V cross W here. It doesn't matter. Right. Next, area of parallelograms. So kind of have sketched real quick like that. So do the 5p1, p2, P1, P2, the vector is the point P2 minus P1. So will be -3, 6, and 5. Actually, we have one vector here. So we do have the formula for that. Yeah, that. We do need to have the adjacent side, so we do need to have this. So P1, P4, which is P4 minus P1, P4, 0, 3, 13, minus P1, so -7, +8, and +8. Right, and then we just do the cross product of these two, just the cross product, and at the end we will find the magnitude later. So I, J, K, -3, 6, 5, -7, 8, 8. Right. So I'll skip a few steps here. So 48, 48 minus 40, so that is 8i. The middle one, negative. -24 and plus 35. Just do this. -24 plus 35, 35 minus 24, so that 11. J, and then plus -24, 24 and 42. Be 66. Sorry, 42 minus 42 minus 24, that is 18, 18k. Right. And then we find the magnitude of that. A square, -11 square, 18 square. It's 509. So it's that. Yeah. So we need to find P1, P2, just the two adjacent sides, and then do the cross product. And need to check the magnitude, because the cross product is a vector. We need to find the magnitude of it, which is a number. Right. Next we go to. Let me update the list. Right. Parabolas. Where is that? Right. So the formula will be over there. Right. The parabola, we need to know where's the vertex, where the focus. The focus is not on the graph. The vertex is on the graph. So let's just try to plot them. So doing 39 here. The vertex is 4 and 3. And the focus is 7 and 3. I mean this. So 4 and 3, 7 and 3. So this will be the focus. Next, since the graph will go through the vertex and around the focus, so it will be like this. Just get a sketch. So kind of like that. This is a parabola that open to the right horizontally. So we will have the form x minus h squared equal to 4a y minus k. Sorry. Y minus k squared equal to 4a x minus h. Right. It's open to the right. So look at the first one here. Right. Now we know put h and k here, so we have y, which is h, that is k. And then a is the distance between the vertex and the focus. If it open to the right, it's going to be positive. So we have this is distance 3, so we have y minus 3 squared equal to 4 times 3 x minus 4, which is y minus 3 squared 12 x minus 4. Right. We do need to sketch to get the idea of what the graph of the function look like. Right. Do 40 as well. Next, 8 and negative 3 and 8 and negative 5. So we have the vertex here, the focus here. The graph always go through the vertex and always go around the focus. And the distance here we do know is 2. Right. This is a parabola that will open down, up and down parabola. We start with x. In this case, h and k, we have x minus h squared equal to 4a y minus negative 3 x minus a squared. 4a is 2. Right. Of course, we need to do one more thing. And that one more thing is, if this one open down, it will be negative. Yeah, just using red. It's open down, it is negative. And a is always positive. So have x minus a squared equal to negative 8 y plus 3. Right. So I have to kind of sketch the graph and see where the parabola opens up. I mean, where's the direction of the parabola or opening, and then we can determine if it is something x squared minus y squared minus x squared, and if it is positive or negative. Right. Next we will find the vertex, the focus, the directrix, and then try to graph the parabola. Right, so on this one we know we have y minus 4, x minus 3, so x equal to 3, y equal to 4. That is the vertex. Right. And this, when we have a positive and y squared x, so that is the parabola that open to the right because it's positive. So we just can sketch like that. Because it open to the right positive, we have y square, so that definitely horizontal and open to the right. Next, we know that it is like that. This have to be equal to 4a. So in this case, a is equal to 3. So if we go 3 units to the right, that will be the focus, and 3 units to the left, that will be the directrix. So we have directrix is y equal to 0. Sorry, x equal to 0. Sorry, that is the vertical line, so x equal to 0. I should write the y-axis, or x equal to 0. And then the focus, where the graph goes around it, we have y is still equal to 4, and x is 3, 4, 5, 6, 6 and 4. Right, so kind of have to know the relation between this, the graph, and the equation. Right, talk about equation. This one did not give us directly, but what we can do is this. First, we do the completeness square. We will add something to it on both sides. And that something is going to be half whatever that is, and then we square. Half of that is 4, and we squared will be 16, and we add on both sides. The left side will be equal to ay minus 40, and the right side will have a square that has 4 in it, and then will be just x and the minus sign. So if that is the equation, and then we can just find the rest of the information. So if we write like this, we have the equation, and the rest should be simple. Right. So that is the problem. So once again, we need to know the vertex, the focus, and the directrix. Either that, the equation, and how they related. Again, the graph will open, always go around the focus, and we'll go through the vertex. Right. So for parabola, we did 39 to 41. Now we go to ellipse. Sorry, we need to reply to text real quick. Right. Next we have ellipse. Right. Of course, the formula is there. Alright. So for ellipse, with different things. So first, for this equation, we have the equation already. We know that x minus 2 and y plus 1. From here we have h is equal to 2 and k equal to -1. So the center will be at 2 and -1, 2 and -1. Right. Next, we will take the square root of this number, square root of that number. It's pretty much 3 and 4. It doesn't matter which one is A, which one is B. It's not really important. What we need to know is that the 4 is below the X, meaning that from the vertex we go 4 units to the left and 4 units to the right. Also 3 units up and 3 units down. So we draw a box. I'm sorry. The box. Like that. And the ellipse will fit inside that box. Right. Right, so we have the ellipse. That's easy. Now we need to find the focus. I mean the foci, 2 of them. So since this one is kind of horizontal, when we draw that we see, we know that the foci is somewhere in here and somewhere in there. And the distance from the center to the foci is always equal to c. Right. Now whether, of course, we have the formula b squared plus c squared is a squared. That's not really important. What we see here is the biggest sine is going to be 4. So Pythagorean theorem, we have 4 squared by itself. The other sine we don't know. 2 smaller sine will be c, and then b, which is 3 squared. And do this, we have c squared equal to 16 minus 9 will be 7. So c is plus or minus square root of 7. Right. And finally, from the center, we go to the foci. That is what we have for the center. Since this one is horizontal, so we need to do, we're just going to put this next to the x-coordinate of the first foci, and that's all we have. So it's very important in hyperbola and ellipse we have to know where the box is, and then we find A, B, or C. Notice in this case A, whatever that is the biggest number. 4 is the biggest one out of this. So I put 4 square by itself. The other 2 square will be on the other side. We mentioned this in class. Alright, so that is 43. Kind of similar on this one, but remember the standard form. We have to divide by something. To have 1, so in that case we have to divide by 324. And whatever that is, because I'll let you figure that part out. Okay, now we will graph. First in this graph we have the foci is -4 and 1. And -4 and -5. Right, those are the 2 foci. And the center must be right in the middle. The middle of those 2. So look like will be -4 and -2. So first thing we have is the center. So try to put things together. We will have the form for the ellipse will be x minus -4 square over something square, y minus -2 square over something square equal to 1. So we have that already. Next, the length of the major axis. The major axis here is 10, and look like this is going to be the vertical ellipse. So the major axis is going to be this, and this is 10, meaning we have 5 each, so will be 1 point here and 1 point there. So the ellipse will go like this. The only thing need to determine is what is the width on that side of the ellipse. So that be B. So in this ellipse we have 5 is the biggest distance, so we're going to put 5 square by itself, and then we have B square, which is smaller, and then C square, which is 3. So from here we have B square equal to 16, so B is plus or minus 4. Right. Finally we have B is 4. By the way, the B will go in the X direction, so I have 4 square here, and the bigger one on the Y direction, 5 square. Yeah. So like I said, it doesn't which one go first. Just the bigger one will be with the direction of the ellipse. In this case, we know that since the 4 sides align vertically, it's going to be vertical ellipse, and the vertical ellipse have the bigger numbers here, and that is the major axis. And that's what we have. Right. 45, and now 46. First we have the focus, the 4 side, 1 and 5, and negative 7 and 5. Again, the center will be right in the middle. I keep doing that. 1 and 5 and negative 7 and 5. Sorry. So those are the 4 sides. The center must be in the middle. Let's just count. 1, 2, 3, 4, 5, 6, 7, and 8. So we have 1, 2, 3, 4. So be right here. So the center negative 3 and 5. Right. So I will start with x minus minus 3 square and y minus 5 square over something square equal to 1. Right. We know one of the vertex is negative 8 and 5, so we reflect this vertex is here, and because of that, that distance will be equal to 5, which is the biggest one. So the ellipse will go around. Like that. The biggest distance is 5 square, so I'm going to put 5 square by itself. The smaller distance, first we have the 4 side to the center, that is 4. And then whatever we need is b square. So b square equal to 9, so b is plus or minus 3. Right, so we have that. Doesn't matter which one's b, which one's 8. We do know that it goes left and right 5 units. Left and right 5 units, so it have to be this. And go up and down 3 units, so it have to be that. Yeah. So try to tie the graph with the information of the ellipse. Pretty much for anything, we should be able to see the graph before we try to come up with the equation or come up with the information of the conic section. So we have 43 and then 46. a problem. Also, we do need to have the box. So first, let's plot this. Wait, note that again, formula on that side. The center is 7 and 6. 7 and 6. The focus 1 and 6. 1 and 6. And then a vertex 6 and 6. So the vertex is here, the focus is there. So look like it's go horizontally. So the graph, we don't know yet, but it will go like open that and the other direction. Right. That to be determined. Right. What we do know here is the center. So from there, we know it's open horizontally. Horizontally meaning x have to go first. Again, h and k. So x minus 7 square minus y minus 6 square equal to 1. So we start with that already. Now, on the x direction, we need to find the box. So the box is where we go from this to the vertex. So this is just one unit to the left. So one left, one right. So we just that. Next, we need to find whatever it is. So we have the box like this. So the box, we know the smallest distance is 1 square. Again, I don't bother to write a square, b square. So we have 1 square. The biggest one here will be the distance from the four sides to the center. So that will be 6 square by itself. The other one, I will be just write down whatever this is. Let's use b then. Doesn't matter. So b square equal to 36 minus 1 to 35. So b is plus or minus square root of 35. Always have 35 here. Sorry. So x minus 7 square over 1 minus y minus 6 square over 35 equal to 1. So if we want to graph it exactly, first we have the center. We go one left, one right, and then square root of 35 up, and square root of 35 down. So we kind of have the box like this. Next, we will have draw the diagonal for the asymptotes. And the ellipse will be just over the asymptote and touching the vertex and go around like that. And this is the transverse axis. Right, so that is 47. 48. Okay, we have the equation, so that's different. Right, so first of all, x minus 1, y plus 2. So from here, right away, we will get the center h and k, 1 and negative 2. So center 1 and negative 2. Next, this one we go 4. Again, we take the square root, meaning that we go 2 units left and right. 2 units on the left, 2 units on the right. 6 units up, 2, 4, 6, and 2, 4, 6, and we will have a box and the asymptotes. And this one we start with x, so again it will open left and right before we start with x. Right, so that is what is the hyperbola look like. Right, so we have the center. Right, we know that the distance here we go 6 units up and then 2 units to the right. The foci will have to be somewhere here and there. The distance to the foci will be the biggest one, so I put that by itself. On the other side we will have 2 square and 6 square, so that will be 40. C square is 40, so C is plus or minus square root of 40. With that we will put in the foci like this. Originally we have the point for the center, and then since the foci go left and right, we're going to just put that, and we have the foci. Right. Next, the transverse axis is going to be this. So we say this is going to be y equal to -2 is the transverse axis. Right. Next, we have the foci. We have vertices. Vertices, the distance we go 2 units to the left, 2 units to the right. Again, everything will base off the center. And since we go 2 left and 2 right, we're just going to have that. Yeah, as you see, it's just a function of a center. We're just adding C to it to have the vertices, and add C to it to have the foci, and minus a number wherever the distance we go, we get the vertices. And that's pretty much it for this one. Right, sorry, we still need to find the asymptotes. Asymptotes equation will be y equals mx plus b, so y we need to minus the center, so pretty much like this. And then the slope rise over run, positive or negative, so pretty much that equation. So the asymptotes are this: y plus 2 equal to plus or minus 3 x minus 1. So the center is very important. As you see, the center appears in all of this. The foci left and right C unit in this case because it is horizontal, and the vertices left and right also, whatever the distance that we go. Okay, of course when we write like that it looks silly. It looks like -1 and -2 and -3 and 3 and -2. Right. So everything is function of the center. Add something to it, or the slope determined by rise over run. And so that is 48. I'll just finish with 49. So on this one, first the center, as always, center x 2 unit to the right, 2 and -1, that is h and k. Which is here, 2 to the right and 1 down. So that is the center. and then we take square root of this. So we have 3 units on the y direction, meaning up and down. 1, 2, 3 up, 1, 2, 3 down. Wait, here. 1, 1, 2, 3. There. And then on the y direction, on the x direction, 5 left and 5 left and 5 right. We will make a basic box, and we have the asymptotes, which will be the diagonal. And finally, this one with the y subtracting the x, meaning that it have to be all vertically. So we go to the vertex and approaching to the asymptotes. So that's what we have. Right. With that, we cover everything. And on the last 3 topics of the conic sections, we always have to go with the graph. Everything will base off the center for the ellipse and hyperbola. And for the parabola, we do not have the center, we only have the vertex. So everything will base on the vertex for the parabola. And after that, we have to know the relation between the graph and all the information of the conic section. Right. So pretty much that cover everything. Will be on the test 3. I hope it helped you to prepare for test 3.